Welcome to the Engineering Graphics Design Project Guide. The following information is a how-to on how to get your report started for your semester project. We will begin by recalling the engineering design process, looking at the various categories for your project, and understanding how to begin your documentation. Additionally, we will speak briefly about your SolidWorks modules, reports, and presentation guidelines. Recall the engineering design process. We will follow the linear engineering design. We will begin the semester by understanding each of the categories within the design process, ultimately providing an efficient means of documentation for your finalized graphics project. Let's begin with problem identification. Essentially, this involves finding a problem. It entails developing something innovative, meaning new, about either a current product or even developing an entire new product altogether. Whatever you choose your project to be, you must provide a reason for it to be part of a new design. What does this mean? It means that you must find a product to develop. If your current product exists, then find an improvement to something that works or a better means of designing something that currently exists. It also means you must know who this will affect, why your new product will make things better, or why a new design will improve the status quo. Finding it means you must understand what is wrong with it now. In other words, why is the product currently not efficient, and why does it need to be better? Background research. In order for you to develop the problem identification, background research is required. Easiest place to find information on what others have done is to start with a simple Google search. So you start off with the internet. Though this is not the ideal method of searching for background, it's a good place to start. Additionally, attempt to move on to journals and articles that can be provided by the library and professional associations. Reputable sources are the basis for good, authentic research. If your product already exists and you're redesigning something, feel free to look at a competitor's product. And lastly, use the resources available to you. Interview faculty and experts. Generally, most of your faculty are experts in a great deal of current products in the field. Take the time to get to know some of them. Make sure every single one of your sources is cited for the information you provide for your background assignment. Objectives. In order to establish your objectives, you must establish three things: the needs, wants, and constraints of your objective. They limit your design and allow you to come up with something that is manageable and something that you can develop in the course of a month or two for the purposes of this class. Your needs are the must-haves of your project. What is it that your project must absolutely, without question, be able to do or establish? Your wants are what would be nice to have if there was time and money. These things are important, but not necessarily imperative or vital. Lastly, your constraints are the items impeding your goal. These are your obstacles. What is preventing you from attaining your needs and your wants? This could be time, expertise, knowledge, and even money. In order for you to meet your objectives, certain organization must take place. The division of tasks as well as some time management needs to be built. So, as an assignment, you are to develop a Gantt chart from now till the end of class. You can write your team name on the top, your team members, and then every task that you have and that you need to prioritize, as well as who's going to take care of what. You are to shade in who's going to take care of what tasks and what days or weeks they are to do it. Now, the example that I've shown you shows you different days because there are for a previous semester. Take the time to write your own days. In this case, we're not going to have a contest. We're going to have a presentation. This is going to be your presentation day. And then additionally, we don't have to create a prototype. Everything that we do will be computer-based. Now, if you do plan on 3D printing something or creating a test pilot of something, then you can add that to your timeline. We don't have a contest, like I said, it'll be a presentation. Goals. Part of setting up your goals is to develop your working criteria. For this, you must be SMART. What does that mean? You must be specific. What is your goal? Where will it take place? What will your project do? This must be measurable. How will you measure what you're trying to do? How will you determine if it's better than something else that has already been done? Is it attainable? Is it achievable? Is what you're trying to do something that can be done? If you're trying to make a time machine, that's pretty difficult to do. So you want to keep it in a range where you can attain this project by the end of this semester. Is it realistic? Are they realistic in terms of money and time? And is it timely? Do you have a good time frame from now until the end of this semester? Additionally, this working criteria can be established by determining the following. How much will it cost? Will it be difficult to produce? Can you determine how big it will be, what its strength needs to be, and what it will look like? Will it be easy to use? And are there any legal concerns if you're creating something? Is it reliable? Can it be recycled? And is it really what your customer wants? Will your customers want to purchase this? In order to do all of this and to attain all your goals, you must use math, science, and engineering. You must establish this criteria, and it must stem from math, science, and engineering principles. Explain the physics of the problem. Generate sketches. For the most part, you must remember that engineering requirements are generally quantifiable and should measure some form of performance. Can your product perform faster at higher temperatures? How do you measure its efficiency? Once all this can be determined, then your benchmark criteria are established. These criteria can be divided into system functions. You will be able to quantify and analyze your project with these. When you do this, my suggestion is that you brainstorm. Talk to engineers, scientists, technicians, shop workers, and then eventually, if you're a real engineer in a real company, you'll talk to production staff, finance personnel, managers, computer specialists, and all sorts of clients for a specific project. All of this is important whenever you're generating anything new. Make sure that you have some sort of preliminary ideas. This is going to set up your functional decomposition. A functional decomposition is the process of taking a complex project and breaking it down into simpler parts. For example, if you're thinking about using an ATM, you could decompose the process into walking up to an ATM, inserting your bank card, entering your PIN. Well, you get the point. You can think of programming the same way. Think of the software running that ATM. Code for that reading the card, PIN verification, transfer process, each of which can be broken down further. Once you've reached the most decomposed pieces of your subsystem, you can think about how to start coding all those pieces. The same thing works in engineering. You can decompose everything into small parts so that you can generate a whole. Once you have preliminary ideas, you should be able to state at least 3. All these 3 preliminary ideas should have various solutions, explain how each of these solutions compares to each other, and make sure that you include sketches for each of these. Your final design solution is going to have SolidWorks models, and you should be able to determine some future testing Even though you might not get to it in this class, you need to figure out how you could test for durability, ease of assembly, reliability, strength, environmental impact, quality, safety, and maybe some sort of consistency of testing. Before you leave this module, set up your Blackboard Learn, check that you are in the appropriate group, upload the following to Blackboard, submit a type abstract for your project, prepare a Gantt chart for the project, and download the information regarding your report, PowerPoint, and SolidWorks models.